Hello, everybody. My name is Jelena Basta from the Blue World Institute, Croatia. And I'm very honored that I can welcome you all on behalf of the Marginet project team. We will use this opportunity, this online event, to present you the outcomes of our great project. And originally, this event was planned to be live here in Croatia, but unfortunately, like most of the other events these days, we adapted ourselves and we decided to go online. However, this enabled us to have many registered participants. Currently, we are over 30, and we are expecting more according to the registration. So besides me, I'm your host today. With us live, there will be also other presenters that you can see now on their short CVs at the screen. So you can scroll down and meet them like this, but you will also be able to communicate with them live by simply using the menu, the tool that you can find on the top right corner of your screen. You will find the chat, but you will also find the questions, because after each presentation, you will be able to pose the questions, but you can also pose them during the whole lot. Any questions also if you have technical problems or something else. So we will organize for each question the opportunity to answer to you. So basically after each presentation, the presenter will be here in the chat room with me. So we should start with the short introduction of our project. So the full title of the Marginet project is Mapping and Recycling of Marine Litter and Ghost Nets on the Seafloor. And this title actually reflects very well the general objective of our project, which was to set up and test some multi-level solutions oriented to the whole circle, actually, to monitor and map marine litter on the seafloor, to remove it, to recycle it, and to get some products that the outcomes of all these activities we will put on the higher level in the policy making process. So basically what we are very proud of is this holistic approach that we managed to achieve through our activities. Specifically, we were focused on marine litter generated by fisheries and aquaculture activities. So focus on abandoned, accidentally lost, and otherwise discarded fishing gear, known as ALDFG. Since this is an international project, this is a project that is a result of cooperation of the organizations from Italy and Croatia, sharing Adriatic Sea. So we had two main project locations. One was Venice Lagoon at the Italian side of the Adriatic, and the other was Lošinj Archipelago at Croatian side of the Adriatic. Also for us, it was interesting to see how marine litter behaves at the different sea bottom, basically substrate and composition. The whole project lasted for 2 years. Well, it's still lasting because it started on the 1st of January 2019 and it's finishing with the end of this year. The total budget was just over 611,000 euros, and majority of it, 80%, came from the European Maritime and Fisheries Fund through Sustainable Blue Economy call, undertaking through European Agency for Small and Medium Enterprises. One other thing that we are also very proud of is that we managed to also achieve this multi-sectoral approach, because in our consortium we have representatives from the different sectors. The lead partner of the project was, and still is, CNR ISMAR from Italy. This is Italian National Research Center, their Institute for Marine Science, representing actually public institution. Also, we had representatives of the small private enterprises, private companies, which were 3 companies from Italy: Laguna Project, Sintol, and Techne Projects. And as only partner from Croatia. There was a Blue World Institute from as a representative of non-governmental organization. So now I gave you this short intro of our project, and I'm more than happy to leave the floor to our project coordinator, Mrs. Fantina Madricarto from CNR ISMAR, who will more in detail explain you the activities of the project, and later we will continue with other presenters, each one of them presenting different components of our project.
So good morning, everybody. I will now give a project overview and will present you the best results of the project. So what is the marine litter issue? So we know that, for example, in 2018, the world plastic production totaled around 359 million metric tons. And globally, between 4 and 12 million metric tons end in the sea. Most of the litter ends up on the seafloor. So the question is, what do we do about this litter? And this was what we wanted to answer with our project, having a multi-level approach. A multi-level approach because the marine litter issue is a very difficult issue, so it needs to have different aspects to be taken into account. The first step we did is to consider the mapping. So to find the marine litter on the seafloor, because the fact that we don't see it doesn't mean it's not there. And the main results that I can show for this is that we actually, during the project, we developed a fast methodology to extensively map the seafloor with acoustic methods and video. We produced 2 semi-automatic algorithms developed for automatic marine litter extractions, and we developed a research object for that. And we also explored more than 8 square kilometers on soft and hard substrates in Italian and Croatian waters, where we found marine litter to be recovered. So the second step that we wanted to we developed is to actually have a predictive model, so a numerical model that is able to predict where the litter, once it's abandoned or discarded, where it could end up on the seafloor. And on this, we have actually developed the modeling tool to estimate the location of potential seafloor marine litter hotspots. And we can, with this method, since it's a mathematical model where we actually can control the sources, we can separate the different effects, for example, from aquaculture, dismiss of debris, or fisheries material that is discarded or lost in the sea, for example. And so we produced maps of marine litter hotspots in the Northern Adriatic Sea. Here you can see an example of these hotspots where the areas are red is where litter accumulates a lot, following the model. So the next step is, what do we do after we have found the litter? We need to somehow collect it, remove it, and do it in an environmentally sustainable way. This is a very important point. So for this step, we during the project we carried out 36 dives for ground truthing of the acoustical mapping and removal activities, and more than 100 kilos of marine litter was removed in Italian and Croatian waters and correctly disposed. So the next step is, once we remove the marine litter from the seafloor, what do we do with that? So this is really a bottleneck in all the treatment of marine litter, because marine litter is very dirty and it's very difficult to be recycled mechanically. So what we did in the project, we developed and tested a low temperature pyrolysis prototype that that recycles marine litter and transform it in marine fuel. So over in the project, we processed more than 250 kilograms of material of milliliter without pretreatment, and we obtained a yield for the milliliter fuels about 50%, so for 50%. Of course, this is a small prototype, but the yields could improve if we go further in the development of these techniques. So another important point that was reached in the project is that actually, if we use the prototype produced fuel instead of the normal marine fuel, we will reach a reduction of 0.75 ton of CO2 equivalent for each ton that is used. So it's not only it's a very nice way of recycling the milliliter, because it doesn't need a pretreatment, but it is also environmentally sustainable. Involvement. So the involvement of fishermen, stakeholders, and citizens is also really, really important, because, of course, it is not just a matter of technology. We need to involve society and all categories that are connected to milliliter, to reduce at the source milliliter, and also to manage to recycle and start new best practices. So for involvement, we did really a lot of activities. We tried to involve fishermen through infographics, questionnaire, demonstrations that took place in Italy and Croatia. We did involvement of citizens and stakeholders through events and exhibitions, and we also disseminated the project results through at large-scale events, such as very important fairs like Ecomondo and Fair in Rome. We also managed to find an agreement with the Chioggia municipality, where there is the bigger fleet of fishermen in the Northern Adriatic Sea, to test the prototype at the fish market in Chioggia in February 2021. This was postponed, unfortunately, after the end of the project because of the COVID emergency, but we will carry out this activity. We have already found an agreement with them, and this will be very important to promote the results of the project. So there is also another question that needs to be addressed: legislation. Now legislation is it's a sort of another bottleneck for the treatment of milliliter, for the disposal of milliliter once we once it's taken, for example, from the fisherman to the shore or to the ports areas. And also there is a restriction of converting milliliter into a new resource. So from the legislation point of view. So this is also an important part, and we have and we are still involving relevant political stakeholders to overcome these legislative barriers. For example, the Onorevole Rocca, the president of the Environmental Commission of the Camera dei Deputati of the Italian Parliament, participated to our demonstration event in Venice and on the 3rd of October. So hopefully the project had a lot of media attention, and we hope that all this media, to use also this media attention to induce also legislative changes. So this is also a way of, pushing from our side the political stakeholders in this sense. So what are these? To summarize, we want to close the circle. So at the end, we want to have a better management of waste import, a less waste left at sea. That means a cleaner sea, a healthier fish product, and also, the involvement of the fishermen and the better safety for the consumers and for fishermen for their products. So let me thank you on behalf of all the Marginet team, and thanks a lot.
Okay, thank you, Fantina, for this overview. But before we move on, and before I give you the opportunity to communicate with Fantina, I'm encouraging you now again to put your questions in. We will have a little break with the video that is showing results and showing the flow of our marginate project.
more deeper into the part of calibration high resolution mapping of milliliter on the seafloor. As I said, how do we map the milliliter on the seafloor? What are the best methods to map the presence of the liter? We did a very extensive review of different methods in a recent publication that came out this year. And of course, the effectiveness of the method depends on how fast you can map, what you can map, so the target dimension, the depth where you can use your methods, the bottom type, and so on and so forth. We actually we actually applied acoustic and video monitoring. So acoustic, very high resolution multi-beam data or high resolution scanning sonar data, so acoustic data combined with images collected by videos or drop frames or ROV or divers can give really very good results for macro liter that you can see, for example, in this picture. And so we carried out specific field experiments and acoustic data calibration. The field experiments took place last year, and we use it to measure the sinking velocity of the milliliter, because sinking velocity is something very important for the modeling activities, to know how fast the liter the macro liter can sink. And then also we wanted to assess actually the potential of acoustic instruments to detect liter and nets, because it's absolutely not trivial to see this kind of materials. And also, we wanted to develop algorithm to semi-automatically detect the liter from the acoustic data. So we did it in front of our institute in Venice. Here you can see the different kind of liter that we used. We were focusing mostly on aquaculture and fishing material, discarded nets or ropes or things like that. And we actually managed to obtain these results. So the multi-beam ecosystem can certainly detect milliliter nets in the water column. And we developed two research objects. Research objects are, so to say, are completely flow of research where you can really reconstruct everything. You have the data, the metadata, and the algorithms, and they are now open and reproducible. And so they are in agreement with the FAIR principles. So to be used and reproduced easily by everybody. Moreover, we actually estimated the sinking velocity of all these different materials, and the results of this data that are not available in literature have been used for the modeling activities that will be discussed later on. Here is an example of tires in the Venice Lagoon that you can see. We saw it before, and also another example of a tire that was detected in the area of Loscini with the high-resolution scanning sonar. So high-resolution bathymetry can be very useful to detect and to classify. You see here also classification of different type of macrolithers on the sea floor. Moreover, also here you see the ground truthing and removal activities that were carried out using the acoustic data afterwards. This will be discussed later as well. And to summarize, we have developed a fast methodology to extensively map the seafloor and to really, be able to highlight the presence of macro liter hotspots. We have developed these two semi-automatic algorithms to extract milliliter, and we actually explored more than 8 square kilometers on soft and hard substrate in Italian Croatian waters. Thank you.
Okay, thank you, Fantina. That was the first in the set of presentations that will introduce you to our project activities. Now I'm asking Fantina to turn on her camera so we'll be able to see her live. And I see that we also have some questions for her. She will be with us in a minute. Hello, Fantina.
Hello.
Oh,
Good morning.
good morning. So before I ask you the question that we see now here, I just wanted to ask you as a project coordinator, what was your overall opinion of the project flow?
I must say, not because I'm the coordinator, but I think it was a perfect project because we were a small partnership with everybody was very enthusiastic, and I think we worked really well together, and everything went smoothly, and we had a lot of also mediatic response, and I think very good results. And so I'm really happy, and I mean I'm a bit sad that the project is about to finish, to be honest.
Yeah, I feel the same. So as you all could hear, that basically Fantina, besides being a project coordinator, she was in charge for mapping and high resolution methods. So we have one question regarding that. Henrietta Belagishan, and she asked, what is the minimum size of the object at the seafloor that you were able to identify with this method?
So this is so the dimension depends, of course, on the resolution of the acoustic equipment that you're using. With our equipment, and also depends on the depth where you are operating. So with our equipment, we could reach with the 10 meters of depth, we could reach so 5 centimeter resolution. That means that we could easily see objects that were so macro litter that was bigger than 50 to 1 meter. So it's you with these methods, just with acoustic methods, you will be able to identify macro litter hotspots. So this is the answer. Of course, this is one application that you can do, but if you think that if you think, yeah, so this is the answer, but you know it depends on the kind of equipment that you have. You can also reach better resolution with other equipments, like for example with side scan sonar or synthetic aperture sonar. They reach even millimeters. So the resolution depends on the acoustic equipment that you have.
Okay, thank you, Fantina. We also have another question. Is there a plan to continue the activities in this project?
Yes, indeed. We managed to win an H2020 project called Maelstrom that will start in January. So we will certainly continue the activities. And we will then develop during this new project new technologies also for the removal part, because of course now in this project in Marginet we relied mostly on divers for the removal activities. But in the Maelstrom we want to really develop new technology for the automatic removal in coastal areas, where we will build a floatable platform with the robot that will clean the seafloor in a very efficient way. This is so stay tuned. January we start a new project.
There is to be continued. Okay, we have 2 more questions before we pass it on to another presenter. Irene Martini is asking, is the method robust enough to use it in other marine areas?
Sure. Yes. I mean, it's absolutely. I mean, of course, we tried in close to our house, so to say, in front of our institute and in our areas and in Loscini, but it's certainly can be applied to other areas. It depends, of course, on the depth. We might want to use, instead of using, if you have deeper waters, if you want to map it, then maybe you better use an AUV instead of a multi-beam mounted on a ship or on a boat. But if you have an AUV flying close to the seafloor, then you will for sure find what you're looking for. If you're looking for marine litter hotspots, you will for sure you will find them. So this is, but the method is absolutely extendable. And to be honest, we also had another project where we, in other area, independent from MarginNet project, where we did really that. So we were looking for dismissed marine litter, and I must say that was really, really very efficient.
Okay, thank you. And did you use a different system that could help you detect marine litter in the water column close to the seabed?
So in the water column, the acoustic methods are really very, very efficient, I must say. In the water column, we can see the small pieces of gill nets, like really very, very small object, even less than 1 meter. So in the seafloor, of course, it's more difficult because you might have rocks, you might have other things that can cover somehow or mislead your interpretation of the data. In the water column, I think it's really effective. We use also, as I said, we use the cameras, we use the drop frames. Of course, these are, also acoustic is always a remote sensing, so to say, acoustic remote sensing. And so you need also to have a look at what you are mapping. And so I think the best, at the end of this project, after all the also literature review that I did during the project time, I think the best option is to combine the two. So to have an acoustic mapping that can really explore large areas, and then really use also videos that goes to check the targets identified by acoustics. I think this is the best way to efficiently map the seafloor.
Okay, thank you, Fantina. I think that was all for now. If you have some further questions, you will be able to communicate with Fantina also at the end of the event. And now we will proceed with the presentation of Ms. Nicole Getzo, who was working on the calibration and on the development of modeling for simulation of dispersion of the marine litter at the seabed. So, Nicole.
So, hello to everybody. I am Nicole Getzo. I work for CNRISMAR. I'm glad to be here in the final conference of MarginNet project. I go to present a small part of the study of this project. It's a part on modeling of marine litter and simulation of dispersion in the sinking marine litter. So, a small overview of our topic in this presentation. We will define the location of different sources of marine litter. We will chat about the SHYFEM model and the marine litter sinking characteristics. I will explain a bit the numerical experiments and our results on hotspots from modeling in comparison with the field data. The aim of this study is to identify the potential hotspots and distribution of marine litter on the seafloor to help the removal activity and the mapping activity in the future. So, So the location of different sources from fishing activity. Fishing activity producing marine litter are the fishing in a small and medium scale and the aquaculture activity. We mapped this activity in the Adriatic Sea. You can see fishing activity on the left and aquaculture activity on the right. You see the fishing activity is coastal but also offshore, and the aquaculture is distributed mainly along the Italian coast but also in some points in the Croatian coast. So SHYFEM model is an hydrodynamic model coupled with a model simulating the dispersal of particles in the Adriatic Sea. We applied this model to simulate the dispersal of particles for 1 year under realistic forcing condition. The red points in the map are the rocky bottom, where particles are trapped on the bottom, and the net on the basin represents the numerical grid we used to calculate the circulation and the particle trajectories. On the right, you see a picture of a sinking net detected by multi-beam. We measured the sinking velocities of different objects used for fishing activity. In our results, the most part of objects sink very fast, but there are small nets sinking very, very low. So we considered these objects for our simulation. So the numerical experiment and the setup of the model, we used the SHYFEM for 1 year-long simulation. We decided that when particle arrives to rocky bottom, they stops, and we applied a very low sinking velocity. We released particles separately in aquaculture areas and in fisheries areas. Every day we seed 1,000 of particles. And we defined 2 descriptors to assess the simulation results: the density of particles on the bottom at the end of the simulation, and the percent of particles beached or staying in the water column or stay on the bottom. So now we go to see some results. This is the aquaculture area. We divided all the aquaculture farm in 4 groups. Here you can see on the right the group in the Gulf of Trieste, and on the left we depicted the particles on the bottom at the end of the simulation. So you can see from the Gulf of Trieste, particles arrives not so much in the middle of the Adriatic Sea. Some particles stay along the Croatian coast, and the most part of particles are beached. We made the same calculation also for the other groups from aquaculture plant in the Gulf of Venice. So you can see now the beached particles are much less. And also for the other groups. So you can see from the Italian coast, the middle Italian coast, the dispersal of particles at the end of the simulation is great, and we found a lot of particles on the bottom, and also for group 4. So at the end, we calculate the density of particles on the bottom from aquaculture sources, and we compare it. So you can see the results on the left, and we compare it with the available data from Aqualit project, reporting the number of marine litter found on the seafloor. In our model, the rocky areas are full of particles, full of potential items, so represent an hotspot, and also some area far from the coast. So this results is in agree at general scale with the data. And also for marine litter seeded on fishery activity areas, we obtain the results to find another 2 or 3 potential hotspots of marine litter in agree with the field data. So we can conclude that we developed a numerical model able to assess the location of potential hotspots. Despite several knowledge gaps as intensity of sources, threshold of resuspension, our results are comparable with field data of marine litter on the seafloor. And the modeling can help to assess the location of marine litter accumulation, but also to evaluate the potential influence of different sources. So that's all. Thank you for attention.
Okay, hello Miko, she's with us
Hello.
today. She has a Christmas tree.
Yes.
thank you for the presentation. We have one question for you. So Eleonora de Sabata was wondering, how much floating litter did you find in the water column compared with the seafloor litter? Are you able to answer it, or should I address it to someone else?
I have not estimated this quantity. So in this moment, I cannot say very well this. I cannot answer very well. Also because we were simulating only sinking litter, and we used a sinking velocity estimated by some objects, but we don't have a proper mix of different objects in the simulations. So it's a very interesting question, but I cannot answer in this moment, also because we made a simulation for sinking objects using a sort of representing sinking velocity for a group of objects. So I have not included all the typology of marine litter.
Okay, maybe also at the final session, Fantina will be able to answer this question regarding this topic, because also during their mapping activities they were maybe looking at this part. But also we have another question that is really addressed to you, Mikol. Will be the model available for other projects?
Yes, of course. I will be happy to verify our model in other application also, because of course when you do the model you approximate the reality, so we have to test again our approximation, so it will be nice.
And can the model account for the different characteristics of marine litter, size, density, shape?
In theory, yes, but it's very difficult to do practically this, because we can take account of different density. But for shapes, it's different also to define the shape of every object. So at the moment, we simplified the geometry and everything. Our model is considering not very detailed shape. But it is possible to develop this part. It was out of the aim of this project, but I think it's possible to develop.
Okay, thank you. And now I will use this opportunity that we have Mikol here with us. As a coordinator of communication activities, I must say that I'm so thankful and I'm so happy for the project teams that that really put an effort besides their scientific research part. They really put some effort in communication activities. And one of them was also Mikol, who was, we had very original ways to present our projects, I must say. We were cooperating with the artists a lot. And the latest project is the one where Mikol was in charge for, she was involved with. So I will ask her just to maybe share with you some nice invitation to visit one exhibition in Venice. So Mikol, can you tell us something about it?
Yes, so we organized this exhibition. Is the on-street exhibition. It means that the location uses some very big windows to involve the people walking to take a minute to see the photo, the exposed photo. So I meet this artist. She's working in London. She's very famous, and she agreed to give us some photo on plastic litter. She do this very beautiful composition. It seems the plastic litter seems some marine life. When you see for the first time, it seems a very beautiful marine ecosystem. But if you look more carefully, you realize that it's only plastic. So it was very nice to join this artistic view with our project, because it's very important to involve emotionally people. So I don't know, there are some, this exhibition was organized with a gallery in Venice, and I don't know if I can show you a photo, but I don't think we can share the screen of computer.
Yes, I don't think that we have this technical option. However, sorry. However, I just wanted to add that the name of the artist is Mandy Baker, and the exhibition is called Net. And it is, besides her artistic contribution, there are also some nice photos from our Marginet project and description of our project, and some films. You can see it live in Venice in the gallery
Anita, vai di là.
And I think it was a great way to show our achievements, and I can say that this whole webinar, this conference event, is recorded, and we will also you will be also able to see it there. We will send them the recordings of this video that will be then shown in one of the windows, as Mikol said. Okay, good. Thank you, Mikol. I suggest we proceed now with the marine litter removal activities. And the person in charge for that was from Laguna project team. And I leave you with Federico Riccato.
Good morning, everybody. My name is Federico Riccato. I am partner of the company Laguna Project, responsible in the Marginet project for the marine litter removal activities. The title of my presentation is Sustainable Practices in Marine Litter Removal. First of all, I want you to focus on a sentence that it's quite commonly used. The sentence is, prevent is better than cure. When I was young, I thought it was the slogan of television advertising of a famous past tooth in Italy, Mentadent, while I discovered recently that it's a sentence of Erasmus of Rotterdam. And it's quite good to describe the activity of marine litter removal. It's not good to try to find something that it's on the bottom of the sea, because it's really time consuming. It's difficult to find marine litter at the seabed and to plan the removal with long standby periods due to weather condition. It's not cheap because you have to involve a lot of specialized people, expert in acoustic monitoring, scuba divers, sailor, you have to use boats and so on. And sometimes it's an unsafe activity because scuba activities may be conducted sometimes in turbid waters with the presence of strong currents, low temperature, and so on. So let's take a look at what we have done during Marginet project. We follow an algorithm. We found marine litter. We evaluate and plan the removal of what we found on the seabed. And we try to remove and correctly dispose all the things of anthropogenic origin we have found on the seabed. So probably you have already seen how we found marine litter with acoustic methods. We use combined multi-sensor high accuracy methods, but unfortunately these instruments cannot give precise information of which kind of marine litter or which kind of eco we have found on the seabed. And so we had to do an activity called ground truthing. For each ecos or non-natural signals received by the instruments, we had scuba divers that went underwater and tried to identify the origin of those signals. For example, here we can see clearly a signal registered by the HRSS instrument, and we had to do a scuba dive in order to see that this was a net lost near the shore in front of the Venice Lido Island. And so all these activities are really time spending and were done both in the Gulf of Venice, 23 times for ground truthing in Venice, and in Lucene Island. For each target we found, then we evaluate removability and plan the removal activity. And so we decided to do this only if there were some condition. We tried to remove marine litter only if it was possible without damaging organism species, focusing on particularly on protected species or habitats. Doing this only if the removal activities could be carried on in safe condition for the personnel and for the environment, and only if it was correctly identified the type of marine litter and the pollutants linked to the particular type of marine litter. So we have got some example here of target found. Here we've got an engrossing organism built up over a troll net. So we identified the type of net, and here, for example, we got weight used for trammer fishing. And in each case, we decided how it was the better way to remove, and if it was possible to remove each marine litter target found. So at the end, we can say that Marginet has capitalized and strengthened removal protocols that were previously started with the Life Ghost project in 2013, in which we were involved, and we demonstrate that these protocols could be widen the range of activity to the eastern side of Adriatic, but probably protocols and techniques used in Marginet can be used in the whole Mediterranean area and probably worldwide. And the goal, the achievement, the better achievement reached was that the plastic material removed from both the Italian and the Croatian sea were dried and prepared for conversion. In fact, more than 100 kilos of plastic materials were sent to Torino, to Synthol Company, in order to convert it into oil. Thank you a lot for your attention.
Okay, thank you, Federico. Federico is here with us today. Hello.
Hello, some trouble with my PC.
So yes, I would agree with Federico because during this year and because of the COVID-19 situation, in the end, the biggest challenge, one of the biggest challenges of the project was actually collecting and sending the marine litter from Venice to Torino to be converted. Am I right, Federico?
Yes, it was tricky.
Yes. So I don't see at the moment questions for Federico. He was also, I must say, with his Laguna project team and his colleague Riccardo Fiorin. They were those that also saved the activities in Croatia because they were the only ones that were able to come and do the research activities on this side of the Adriatic, also because of the COVID-19 situation that prevented us and we needed to adapt. So there is actually a question for you, Federico. Does the marine litter needed any pre-treatment before sending it to Torino?
Probably Gian Claudio can explain better the pre-treatment to the marine litter. We only dried up the things and sent them in a black box to Torino in order to be processed by Gian Claudio.
Okay. then actually we can invite now Gian Claudio. Thank you, Federico, for now. We will leave the floor. So we detected the litter, we removed it, and then the next step was to basically recycle it. And for that, we used our wizard company, Sintol from Torino. And I'm leaving the floor with.
Thank you for being here to listen to this presentation about our work package number 4, so the application of low temperature pyrolysis to recycle the marine litter. So first of all, definition, what is marine litter? I think it's worth reading the statements, because marine litter consists of items that have been deliberately discarded, unintentionally lost, or transported by winds and rivers into the seas and beaches. It mainly consists of plastic, wood, metals, glass, rubber, clothing, and paper. From this first statement, it's clear that marine litter is not just plastic, but since plastic is the most persistent pollutant, it deserves a special attention. And by taking the words of the Director General for the Environment of the European Commission, marine litter is a growing global problem which poses an increasingly serious threat to the environment, the economy, and health. And to rid our coast and seas of marine litter, we need to understand its various sources, forms, and impacts, and come up with imaginative, concrete, and ambitious solutions. Meanwhile, we must all reflect on what we choose to buy and discard to reduce the amount of litter ending up at sea. I think that this statement really encompasses a lot of the problem connected with marine litter. If we start from the end of this statement, marine litter basically should be prevented. So it's a matter of waste management, indeed, but first of all, we should avoid new provision of marine litter going into the sea. But then we have to consider that there is a huge amount of marine litter already present in our oceans, and we need to find imaginative and concrete solutions to tackle the problem which exists. And so this is what exactly we try to do during Marginet project. So marine litter is a problem of waste mismanagement and the lack of pragmatic solutions. Of course, all plastic is generated on land, but from this publication published in 2015, there was a certain estimation how many million tons of plastic waste and marine litter enters in the ocean, and in this case was just in 2010. And the figures predict that these numbers are going to increase by an order of magnitude by 2025, and means tomorrow. I mean, we are very close to this, to scale up to an order of magnitude of these numbers. And if we make some calculation, we can even think that about from 32 to 86 million barrels of oil equivalent flowed into the ocean just in 2010, with an equivalent value of up to $5 billion. So indeed is a problem of waste management, but it's not so easy to, there is not a single solution to deal with the problem, and we will see why. First of all, some facts about plastic waste. We must understand why there is so much marine litter and why these countries in the Far East are considered the most responsible for marine litter flowing into the ocean. Well, in the European Union, about 31% of the waste plastic which is collected, so it means which is separated from municipal solid waste, is accounted as recycled, and almost 70% is still burnt or landfilled. But when we consider the recycled plastic, this is not always true. Some NGOs have discovered that actually this waste trade in Southeast Asia actually are causing a lot of problems, and those recipient countries are facing a lot of environmental issues. And we have to consider that those countries are indeed responsible for the plastic enters into the sea and the oceans, but some, not to say most, of the plastic that enters into the ocean actually comes from United States, North America, and Europe. So I'm not saying that all the plastic which is sent to those countries as recycled is dumped or burnt in open fire, but indeed there is some percentage of this plastic which is actually accounted as recycled in Europe, but at the end ends up to be marine litter at the end. But why? I mean, we always say that waste is a resource. So why there is so many problems? Well, first of all, we have to understand what recycling means. Usually people think about recycling or mechanical recycling, so making an object out of another object. But it is not always technically feasible for heterogeneous and contaminated waste. You know, the process of recompounding polymers which are not pure sometimes is not technically feasible, and so at the end, plastic cannot be recycled this way. And besides, we have to consider that very often recycling is actually a downcycling. So the production of low-value fibers, which, by the way, can even pollute the oceans by releasing microfibers. And there is an interesting publication about that. And then we have to also consider that mechanical recycling is not a perpetual cycle. Plastic is not a metal. So even if potentially it's possible to recycle plastic to make new objects 2-3 times, most often it's just one time. And remember that sooner or later, every recycled item will become a waste. So to come again to the initial statement, our imaginative and concrete solution is the chemical route. Because since marine litter is retrieved during day-by-day activity by fishermen, and since mechanical recycling is not an option for marine litter, we decided to go for the chemical route. The chemical route means to recover the building blocks of matters and synthesize new useful products for stakeholders, which are not limited to be new objects. They can be products. And within Marginet, we explored an option to convert marine litter into useful marine fuels, compliant with the standard, because even if something burns, it doesn't mean they can be qualified as fuel. So we want to convert marine litter into fuels that can be used legally and readily available for stakeholders. And in our view, this is a pragmatic approach to marine litter, but I would say also for heterogeneous plastic waste in general. Because this approach is flexible, is relatively insensitive to waste type, and relatively easy to use, we can focus on specific products, in this case fuels, which can get the involvement for stakeholders. We can really have a direct feedback, a direct incentives of the marine litter and the waste they provide. And also we think it's a good approach to make marine litter problem a decentralized approach, which is appropriate in our view for dispersed pollution like marine litter. And the ultimate goal is to trigger a virtuous cycle of depollution and sustainability through value generation. So clearly, the Marginet concept is to help the stakeholders, in this case, the fishermen, to give a value and the use of the collected marine litter and use nets. So turn marine litter into marine fuels that can be used directly to power the depollution cycle. So in a virtuous cycle of sustainability and, let's say, circular economy. So what is pyrolysis? We said that we are using the pyrolysis to go through the chemical route. Well, pyrolysis is derived from the Greek pyro and lysis, but actually is not a combustion, nothing burns. Pyrolysis, generally speaking, refers to a thermally reversible decomposition in an inert atmosphere. So under the force of heat, materials and matters undergoes a degradation, which leads to the formation of different molecules, which can be rearranged and shaped thanks to catalysts and additives to desired outcomes, in this case, like fuel. It seems easy. It's not so easy. But indeed, once the chemistry is well understood and well put in place, this is a quite powerful solution to deal with heterogeneous waste, as we will see. This is a picture of the small prototype built and used during the Marginet project. It's basically composed of two units: the pyrolysis unit itself, which is what you see here, which is responsible to produce the raw pyrolysis oil, which is then will correspond to this section, and the distillation system, which actually fractionate the raw pyrolysis oil into useful cuts and useful fuels. These are pictures of taken during the testing of the prototype with actual marine litter collected from the Venice lagoon. Marine litter was processed as it is, so without any pre-treatment at all. We have to say that the marine litter that was delivered was very contaminated, and there was a lot of organic matters and not plastic material in it. But you can see here there is the collection of the oil that we collect in tanks also for use, some data collection and emission monitoring. So coming to some results, overall during Marginet project we processed overall 250 kilograms of material, of which more than 100 kilograms of actual marine litter from the Venice lagoon, including the fishing nets. The overall product yield from marine yield to marine litter to fuels was about 45 to 50% by weight, and the remaining is split between flammable gas and solid residue. Even if by a simple triage, so excluding what is evidently not made of plastic, we can get even higher oil yield. For the products, we got about 20-25% by weight of light fuel that can be used as blend for gasoline, a low sulfur marine gas oil, which is compliant with DMA ISO standards, around 50%, and an intermediate fuel oil compliant with residual marine fuel standard. And then some water coming from the decomposition of polyamides, so the nylon of the fishing nets. We did not detect any significant level of dangerous contaminants. We monitored 8 substances which are precursors of potentially hazardous substances. And from a third-party survey, we came out with this calculation that the use of 1 ton of marine litter of marine gas oil generated from marine litter, we are actually saving around 3/4 of a ton of CO2 equivalent. So even also from the CO2 perspective, is more convenient. It's better to use this type of fuel rather than conventional one. And then there is another remarkable result is about the sulfur content of fuel, because the International Maritime Organization has set up during the years lower and lower limits on the amount of sulfur for marine transportation. Here in the box you see the maximum amount of sulfur that can be used in marine fuels. And European, the North Mediterranean, and some other areas of the world, like the coast of United States and the Baltic Sea, they are within the so-called the emission control areas, where there is a stringent limit about sulfur content for air pollution prevention. And we can say that the sulfur level that we measured in our fuel is by far lower than the limits set by IMO for the ECAS areas. And in particular, the fuel that we can produce by this way can be classified ultra low sulfur fuel, being below 0.1%. And if you consider the limits, we are about from 80% to 90% less compared to the conventional marine fuels. So we can say that marginal fuel is even cleaner than conventional. There are still some regulatory barriers because there are still some hurdles to overcome to make this approach more widely employed, at least within the EU. The first one, there is still uncertainty about the legal status of marine litter. So, which type of waste classification it is? Do I need a permit for transportation? In Italy, there is this problem of authorization for everything, but if fishermen needs to have a permit to transport this type of litter, so is a problem. And then who pays for the management? I mean, marine litter that fishermen collect in the Northern Adriatic Sea, for example, can come from all the countries in the Mediterranean. So who pays? Then there is still some uncertainty on the chemical recycling regulatory framework. So it's relatively new, and so there is still missing points, missing tiles on the picture. For example, the end of waste matter. So is the produced fuel still a waste or can be considered a product? Because if it's considered a waste, like in Italy, for example, you need a permit from a regulator authority. And fishing boats basically are equated to waste incinerator, which is crazy, but this is the case. And also, what are the authorized fuels? I know the Italian case because in Italian, we have this list of permitted fuels. And in this list, the second generation fuels are not included. So basically, even if compliant with ISO standard, you can even tell which one is a marginal fuel or which one is the conventional MGO. Well, they cannot be used. So my conclusion, marine litter was successfully converted as it is without any pretreatment into marine fuels compliant with the ISO standard. And no significant environmental drawbacks were detected. The oil yield can be improved, so there is room for improvement. And the low sulfur content would enable to extend de facto the ECAS limit at no extra cost. The CO2 emissions are encouraging because it's compared to regular MGO, the emission associated with marginal fuel are lower. The scale up for real application is feasible, but in our view, portability is a key because the centralized approach is essential to get stakeholders' engagement. There are still some regulatory barriers to overcome, as we say, the end of waste, the permitted fuels, etc. But at least maybe this is not the optimal solution, but for sure is a pragmatic solution ready today for heterogeneous waste plastics. And I stress the fact that we need a pragmatic solution today and not in another 15 years of study, because there could be more plastic than fish in the ocean by 2050. And so I leave you with this picture, iconic, of the sewage surfer, which I think is very representative of the health of our oceans. And with that, I thank you for the attention.
Hello, Gian Claudio is with us today with a little bit better camera. So yes, congratulations once again on the achievements of the prototype and great test results. For a start, there is one question from Caterina Fortuna. I believe partially you maybe also respond to it during your presentation, but it's, I think, something that more people are also interested in. What do you do with other types of marine plastic litter, not from fisheries devices or aquaculture? And are there any plans to one day be able to widen the scope of the plastic waste used to make oil?
Well, actually, marine litter is the most difficult feedstock to treat. So basically, we already have experience with terrestrial waste plastics, and the results. I mean, I would say it's even easier. This approach is very flexible about the feedstock. So it's a feasible approach. I would say we get this experience of marine litter, which is the most difficult ways to deal with. So we are pretty satisfied, and we can say we can extend this to almost all type of plastic feedstock now.
Yeah, and I would say that the crucial thing is that that we also heard today already is that for this kind of recycling you don't need a pre-treatment.
Yeah, exactly. This was an important point. I mean, with such contaminated or dirty feedstock, you cannot really go for a lot of pre-treatment because you know, we are all in the market. The more pre-treatment you add, the more cost you are adding to the process, and at the end you end up with a total cost which is unsustainable from an economic point of view. So to get sustainability, I think it's important to have a flexible solution which is not so sensitive to contamination, and in this case we achieve it.
Okay. So another congratulations. How do you plan to go on about trying to regulate and implementing this fuel?
This is a good question. Unfortunately, regulator do not depend on us unless when we go voting. But you know, I've been working in this field for some years now, and I can say that the technology is well beyond the legislation framework. And unfortunately, there are still some resistance from the political side, but also from some industries, which do not really see chemical recycling as a friend, but a competitor. While, in my view, they are very, they're complementary. We complement each other because, as I exposed in my presentation, mechanical recycling is good. I'm not saying that it's bad. It's very good, but we have to think that to close the mass balance at the end, every recycled item will become a waste sooner or later. So there is no reason why we should prevent chemical recycling from being widespread and used more largely, because at the end we are recovering waste which is not possible to recover and in another way. So the alternative is just landfilling or incineration, which is, of course, if we don't consider illegal dumping in the sea. But so there are really no really good reason to prevent it. But still, I think the process and the technology is still unknown, and so we have to make some education activities towards policymakers in order to let them understand that there are alternatives, and we simply need to engage little by little in it and prove it at larger and larger scale, and it's feasible. I mean, it's technically feasible.
Yes. Well, actually, the final activity that we will present today, it's going towards that direction because, of course, as Gianclaudio also pointed out, one of the most important things in the whole process is actually mainstreaming and implementing these results and of the project and sustainable marine litter management practices into the policy making level. So thank you, Gianclaudio, for now. If you have any questions further for Gianclaudio, you can still write them, and we will be with him also in the last Q&A session. And now I'm leaving you with my colleague Valentina Zambetti, who works for Techno Project, and they were in charge for this mainstreaming part.
Good morning to everybody. Today I'm here to close the first session dedicated to the presentation of MarginNet results and to give you some overview about the future scenario of the application of these results. So let's talk about the mainstreaming of MarginNet. And let's start from the meaning of the word mainstreaming. That literally is following the mainstream, but from a methodological point of view, we can speak about mainstreaming as a process where innovation tested at a small scale is transferred into the system. With Marginet, we worked both on the horizontal mainstreaming oriented to change behavior in communities and at vertical level mainstreaming oriented to change the role in the system. In that sense, we involve fishermen and aquaculture operators to transfer the project results, as well as we worked with institutions to make the result of Marginet uptaken in the ordinary law schemes. Let's say that at the horizontal level, the coronavirus emergency blocked us very much in developing the foreseen activities of Marginet in terms of involvement. So we have been forced to find other solutions to transfer our results towards fishermen. And we produce to this purpose an infographic oriented to explain how the Marginet prototype runs and which are the advantages in exploiting the Marginet prototype for fishermen. The idea was to make the fishermen the first line in asking for the Marginet prototype in their port areas. And this was particularly important because from previous analysis we saw that in many port areas, in many fishing areas of the Adriatic Sea, the disposals and the plans for transforming fishing waste was lacking. Therefore, with the cooperation with stakeholders, with fishermen in particular, we would like that the category itself could appreciate the advantages of the prototype in order to improve their image toward communities and toward consumers. In promoting the infographics, we also had the possibility to collect the feedbacks from operators in terms of the usability and the willingness to use the prototype in port areas. To this purpose, we distributed about 60 questionnaires to operators of the aquaculture, of the fishing sector, and we collected the general interest toward the prototype of Marginet and a general need of port facilities in port areas of the Adriatic. What is quite important also to see is that we notice that the waste generated in port areas are enough to make the prototype run, but the demand of fuel is much higher than the capacity at this stage of the prototype in producing fuel. But this is of course an important result because we can consider that there is a need of this kind of prototype and also the possibility to upscale it for functioning in port areas. To this purpose, to have a first-hand idea on how the prototype could be used in port area, we catch also an important result with the signature of an agreement with the municipality of Chioggia and with the ICTIC market of Chioggia, finalized to test locally the running of the prototype. The agreement is up to be signed in these last days of the project implementation, and the test will be conducted in the first 2021, so in February. We are very glad to have this possibility to test at local level the prototype, because this test could give us important indication for the future replication and application of MarginNet results. We, of course, main refer to the prototype, and also give the possibility to the MarginNet project to have an high demonstrative value and the possibility to transfer the results to fishermen. So to couple very well the horizontal and vertical mainstream. Finally, the practical test will give us also the possibility to better describe and to better outline the practical and affordable solution to make the prototype applied to other port area in the Adriatic, and to produce the last deliverable of the project, that is the vademecum for policymakers and institutions. That is made just to allow the policy uptake, a large-scale policy uptake of MarginNet results. And we hope that the vademecum could be a useful tool for all the institutions and management body of port areas in the Adriatic, because it will contain indication also for the application of the new directive 883 issued on 2019 by the EU, and that foreseen also for small ports the application of waste management system, advanced waste management system. So with this hope, I return the floor to Elena and to all other participants for the question and answer session. But before leaving, I would launch the infographic to remind you how all the local fishing communities could contribute to solve the problem of marine litter.
Project, financed by the European Union through the European Maritime and Fisheries Fund, proposes a concrete solution to the problem. MarginNet has developed a prototype that transforms this type of waste into different types of fuel, including marine diesel. The latter is then reused by the fishing boats themselves, thus promoting the circular reuse of waste. The prototype consists of two units. The pyrolysis unit, which transforms marine waste into liquid pyrolysis oil, separates the gaseous flow from the condensed liquid oil and treats it in an environmentally safe way. The distillation unit, which splits the pyrolysis oil into useful products by neutralizing the gaseous emissions before discharging the dissolved gases. In the experimental phase on a small scale, the yields of the prototype proved to be very interesting. From 100 kilograms of nets and plastic, 50 litres of marine diesel are obtained. The advantages are obvious. Using the MarginNet device in port areas contributes to better management of plastic waste and waste related to fishing and aquaculture activities, generating a chain of added value for the environment, for humans, and for coastal fishing communities. At the same time, it gives operators the opportunity to better themselves and take a crucial role in waste management at sea, adopting sustainable practices that respect the marine environment. Only proper management of marine waste can help solve this difficult situation, and collaboration between maritime authorities and fishermen remains of paramount importance. The Marginet device not only helps the environment by reducing plastic waste and cleaning the sea, but also qualifies the coastal fishing communities that use it.
Yeah, good morning to everybody. I basically didn't catch
Oh, sorry.
Elena's
sorry,
questions.
sorry. Yeah, I had a slight connection issue. So, hello, Valentina. Thank you for
Hello,
being with us
Elena.
today. And sorry for this
Everybody, of
inconvenience.
course.
Actually, there is a question that stayed here from after Jean-Claude's presentation, and maybe it was aimed to him, but I believe that you could also tell us your opinion on it. Do you think that the big oil companies could be interested in this method of recycling?
So what I can say is if fishermen could be interested in this fuel. And from what we know from our survey, fishermen are very interested in this fuel, also because they could understand the value of the circular production of this fuel. So they could be, in a certain sense, involved in the production of the fuel, so they are able to use something they do. And as I mentioned in my presentation, the problem is that right now the possibility of the prototype is, of course, limited because of it is a prototype, and the request for fuel from the fleet, for example, the fleet of Chioggia is really much higher than the capacity in this stage of production by the prototype. So the problem, in my opinion, is not the interest in the fuel, but the possibility to upscale the prototype to a level able to reply to the demand of fuel from fishermen.
Yes, exactly. I share your opinion. As soon as there is an interest,
an open question. You know, it's an open problem. We put the first tile of this project with this project, but of course we have to go ahead with the research and testing to have solution that could really reply to the demand of the fish or the fleet.
Yes, as a matter of fact, I believe that maybe some representatives of oil industry and definitely some representatives of policy making sector are here with us today listening. So this is also one step, I guess, towards this achievement. So thank you, Valentina.
Thank you too.
Now we are going to the very last part of our event. Throughout the whole project, I must say that we had a great support and great cooperation with European Agency for Small and Medium Enterprises. The senior advisor for our project was Mr. Vincenzo Gente, who is also here with us. And we are very happy that he agreed to give the final presentation, final words, final touch to this event and to our project.
Hello, everybody. Thank you for the invitation to this final event of the Marginet project. I'm very happy to be here with you. we are coming to the end of the day as well as the end of the project. It has been a very intensive journey with you, and despite the small budget of the Margin project that was granted by the EMFF program and all the difficulties that you and we all had and are still facing due to the COVID-19 outbreak, I have to say that I'm very happy about the results achieved by all of you, by the project. So I would really congratulate with you for this project and for the work you carried out so far. So as you can read in the slide, just because you can see it, it doesn't mean that it's in there. This is really a good motto for the Marginet project that is addressing the Marilita that we cannot see, the one that is not floating. And nonetheless, this Marilita still represents a risk for potential risk for health of our seas, and solutions need to be found in order to map, collect, and recycle this Marilita. The Marginet project is really a good example of how such a complex issues of Marilita can be addressed in an efficient way. In my view, one of the main strengths of the Marginet project has been that it was able to address Marilita with a systemic approach. Marginet was indeed merging different strands, different actions in the project. There are research actions, innovation actions, and at the same time, there are soft measures like engaging with stakeholders, fishers, and also looking at policymakers to find other kind of solutions that are not necessarily linked to technologies. So that's really one of the main points of the Marginet project. And also from a policy perspective, I have to say Marginet is demonstrating also the connection that exists between circular and the blue economy. So this, the EMFF call that Marginet responded to was addressing the issues of Marilita also in the context of EU plastic strategy and single-use plastic directive. At the moment, when the call was drafted and Marginet was prepared, these were the two of the main EU initiatives that were looking at ways for the EU economy to become more sustainable. In the time being, well, things changed for the better as the new Commission is now giving to sustainable growth even a more important role in the EU policies. The EU Green Deal that was adopted just last year is at the heart of the Europe's strategy for new sustainable growth and call for a transformation of all economic sectors. As you can see in the slides, there are a number of initiatives that are linked and coordinated within the EU Green Deal. Indeed, it calls for a systemic change, and the Green Deal is an excellent example that show how we have to go across silos in EU policies if we really want to achieve concrete impacts for our society. So there is no real succeeding in silos, and Marginet, I think it's also an example on how to carry out this approach. Obviously, circular economy has a big role in the EU Green Deal, but the marine sector also makes no exception to the transformation that the EU Green Deal is calling for. The blue economy is really one of the tools that can help support Europe's economy post-crisis recovery through innovative products and services. And this is in line also with the objectives of the Green Deal. Another initiative that is being put forward in the time being is the Commission proposal for the Recovery and Resiliency Facility that is at the centerpiece of the next generation EU. This facility will be a temporary recovery instrument that allows the Commission to raise funds to help repair the immediate economic and social damage brought about by the coronavirus pandemic. obviously this facility is closely aligned with the Commission priorities, ensuring the long-term sustainability and inclusive recovery that promotes the green and digital transition. In the slide, you can see some of the flagship areas that the facility will look at. So you have clean technologies, energy efficiency in building, but also sustainable transport, scale up, data clouds and capacity. So there are a number of initiatives that the facility is concentrating upon, but it has to be put in, kept in mind that the Commission also put specific targets for expenditures for the national plans that will be implemented these facilities. Each recovery and resilience plans will have to include a minimum of 37% expenditure related to climate. And this obviously it's in line with the European Green Deal in terms of environmental objectives. And each recovery and resilience plan will have also to include a minimum of 20% of expenditure to foster the digital transition. So really promoting green and digital transition are priority for this Commission. What is the role for the blue economy? I can highlight the important contribution of sustainable blue economy to the recovery and resilience, in particular through innovation, technology, diversification, and transformation into new green and digital products. And this can be found, for example, in marine renewable energy, blue biotechnology, and solutions for reaching a circular economy. You can also have examples in the EU Blue Invest initiative, which provide assistance and grants to help SMEs bring new ideas to the market, and focusing obviously on the blue economy. The Blue Invest initiative, it's also looking at venture capital backed up by guarantees from the European Fund for Strategic Investment. So it's not only grant, but it's something that looks at blending financing. In addition, one important point is that the spendings that we have to look at will have to do no harm for the environment, meaning that they have to be sustainable. And this is in line also with the EU taxonomy for sustainable investments. This do not harm principle is going to take more and more important role also in future funding programs of the EU. In this respect, I know that Marginet will have a follow-up in a Horizon 2020 project that's already been granted. But I would like also to highlight that there will be soon new EU funding programs with the new MFF. So in addition to the new EMFF, the European Maritime Fisheries Fund, under the Horizon Europe, the Commission will launch a mission in the area of healthy ocean, seas, coastal and inland waters. It will be really a tool to raise awareness of the importance among citizens, facilitate synergies among EU funding programs, and also develop systemic solutions, including for the supporting the transition for circular and blue economy. So for this is something that will happen in the near future, but there are still some funding opportunities that you might be interested under the present EU funding programs. The first one that I would like to mention is the Blue Economy Window Call of 2020 that it just opened on the 12th of November, and it will remain open until the 16th February. This call is addressing for-profit SMEs, and it's focusing on blue economy sectors. What is relevant is that activities for the project could include testing, developing, and demonstrating scaling up new solutions for the blue economy, including technology, service applications, products, processes. It is important for us also that there is an interest from investor side. So applicants will have to submit a letter of intent from investor or customer and also a business plan and a commercialization plan as part of the application. This is basically the follow-up of the Blue Economy Window Call 2019 that for which we have been signing now, I think 10 grants already started. I think the 11th one is starting in these days. Another interesting opportunity for you is also the Horizon 2020, Horizon 2020 Europe Green Deal call that's putting forward 1 billion in the area of to support the objective of the European Green Deal. There are very many different areas addressed in the topics, including energy, mobility, clean and circular economy, farm to fork, zero pollution, biodiversity. And 12 millions are specifically dedicated to topics aiming at increasing knowledge to predict and protect the seas and the oceans. The deadline is approaching, it's end of January, 26th of January 2021, and the selected project is expected to start in the autumn of next year. You can find all the information relating to EMFF and Horizon 2020, as well as other EU funding programs in the Fund and Tender portal opportunities portal. And there you can also apply to this call. You have FAQs, you have many different support for in case you would like to apply to specific calls. So this is all from my side. I really would like to thank you for this event and for what the project was able to reach in these 2 years. And I'm looking forward to see all of you in other successful EU-funded projects, and finally also having your solutions applied on the ground, because this is at the end what we want to achieve for the benefit of EU citizens. Thanks again, and good luck for the future.
Okay, hello everyone again. Thank you, Vincenzo. We seem to lost Vincenzo. I guess he has some technical problems, so we will see if he will be able to join us. Just a second. We are trying to reach him now because there is a question actually for him. And get the opportunity to thank him once again for the great cooperation. However, that was the last part of our today's event, and I hope we were able to basically connect with you and to present you in the best possible way the achievements of the Marginet project. Once again, we will also, okay, Vincenzo is here with us again. Hello, Vincenzo.
Hello, good morning.
Good morning. I'm glad that you managed to connect with us at the very end of this event. There was a question for you posed by Caterina Fortuna. Could you elaborate a bit more on the mission, please? I believe that is a mission of your office, or the...
I think it's the ocean missions, I think she refers to. Yeah, this is where there are some mission areas that have been elaborated, but those are missions within Horizon Europe, that is the new research and innovation program. And these missions are still under elaboration. There are missions boards looking at possible synergies and areas to be addressed in the future Horizon Europe work programs. But it's true that these missions are really looking at synergies across different parts of Horizon Europe, but also how different programs can contribute to this mission. So for the time being, it's still under elaboration. The work programs of Horizon not been adopted yet. There are colleagues and in EASM, but especially in the DGs looking at that for the first calls. As you know, the MFF has not been adopted yet, so there are some delays in the adoption of also the EU-funded programs. So you have to wait a little bit to get to know more about that. But you can find quite a lot of information about the ocean missions also on the web. There are public information available for that.
Thank you, Vincenzo. Since there are no other questions, I will use this moment now to say thank you, everyone, for participating once again, and to point out that in the chat you will find a bunch of links on the videos that you have seen, and also as we wanted to show our great cooperation with media and the visibility of the project. There is a link on the beautiful short documentary done by Euronews film crew about our project. So I'm encouraging you to check them. You can also see all the materials on the Marginet project website, and this whole event is recorded and will be also available there. Before we go back to the other presenters to say goodbye, there is another question for Vincenzo again. The mission on healthy oceans, please see info below. So can someone say something about the mission on healthy oceans? Or this is also referred to the questions that we already had. There is also the link on this topic in the attendee chat. So there are some more actually useful information that you can find there. So thank you once again. Can we see all the other presenters to wave them before our session goes? We a little bit exceeded the estimated time. It happens. Time flies in the flow. So here we are now, and this is your one last chance to say goodbye to the participants. For any other questions, please feel free to contact any of us on our emails that are available at the registration link. Okay, thank you once for joining us.
Thank you. Thank you, everybody. Thank you, Elena.
Thank you.
Thank you, everybody, for attending.
Croatia's island of vitality, Lošinj, is a magnet for tourists and a hotspot for Adriatic wildlife. But like many coastal areas, these crystal clear waters are plagued by marine litter. Each year, 8 million tons of plastic enter the oceans around the world. The pollution's harming the biodiversity, spreading disease and toxins throughout the food chain. These local scuba diving students have volunteered to clean up some of the trash accumulated over the years in an otherwise picturesque marina. We dive together to find the seafloor littered with trash, from bottles and plastic cups to pieces of broken boats.
You see on the bottom a lot of human waste, mostly plastic, nylons, everything that sometimes it's on the beach, then when the wind starts to blow, then can finish in the sea, and there is a big question who will clean that up.
We find old fishing nets and cages piling up on the seafloor, a not particularly surprising discovery. It's estimated that 1/5 of all fishing gear in European waters ends up lost or intentionally abandoned. They can take centuries to degrade and make up 1/4 of all marine litter in Europe. Finding these abandoned nets at sea and lifting them to the surface is not easy. This hazard for marine wildlife is known as ghost fishing.
They're like a trap for
many marine organisms, they get completely entangled, and this particular type of the net is also made of nylon, which is also then plastics that will in the end turn into the microplastics, and this is how we will end up with having particles of microplastics in our body.
Finding ghost nets and other marine litter can be easier with new technology. Researchers from the European project MargNet work here in Croatia and in Italy, testing a high-resolution underwater scanning system.
It's essentially a sonar, but it's located not on the boat at the surface, but directly on the sea floor. The boat can move, drift with the wind, whereas this instrument is steadily fixed at the bottom. Its head rotates 360 degrees, providing us with a seabed map at the centimetre precision. We can see objects as small as this.
The plan is to use this technology to map pollution hotspots, which can then be cleaned up by professional diving teams. This can make underwater cleaning operations more efficient and less costly. As the echo sounder is deployed from the boat, one of the researchers makes a dive to check that the device is properly placed on the sea floor. This acoustic scanner is capable of detecting underwater objects within a radius of 150 meters, transmitting the results back to the boat in real time.
On the screen you can see the round shape of a tyre or the elongated shape of a rope. This system can be used in combination with other methods to identify objects on the bottom, in particular if the water isn't clear.
In this part of Croatia, the Adriatic Sea is extremely clear, but the same technology can be just as effective in murky waters. Like the Venetian Lagoon in Italy. High tides often wash litter off the streets in Venice and straight into its famous canals. But local authorities and activists are now fighting this problem.
Here in Venice and in other coastal cities around the world, cleanup events have become an annual tradition. This volunteer action is supported by local and international organizations. Last year, the European Union, in partnership with the UN, mobilized over 40,000 volunteers in nearly 80 countries to take part in the EU beach cleanup campaign.
Plastic-Free Venice Lagoon is one of the numerous local groups that participated in this year's cleanup. Some volunteers removed floating debris from the historic canals, while others picked up rubbish that had been brought ashore by the wind and currents. Taking a boat to Murano Island, renowned for its glassmaking, we find a less visited part of it littered with garbage. Besides cleaning up, the activists work all year round on raising public awareness.
I think one of the most important things is to get people closer to the problem of marine litter, of how we treat our environment, and try to create a bond that's been somehow cut off in our modern civilization between us and our environment. This is the key to make bigger changes. Much bigger than clean up a little piece of lagoon.
The MargNet research project that co-organized this cleanup believes that plastic waste should be treated as a useful raw material. The bags of litter that we're bringing back from Murano don't have to end up in an incinerator or landfill. We're assured that we'll see how they can be recycled.
These plastics already exist, so you have to collect it, to remove it, and to try to recycle it. That's what we are doing with MargNet project, so that we try to really close the cycle and, of course, to involve the people and raise awareness.
Over a single cleanup day in Venice, this association's collected almost 3 tons of waste, including hundreds of kilos of plastic. These are shipped to Sintol, a small company near Turin that specializes in pyrolysis. Their prototype device breaks down plastic by heating it to 400 degrees in the absence of oxygen.
Pyrolysis is the only known way today to process mixed waste without the need for pre-treatment. As you've seen, the litter is simply loaded in just as it was recovered from the sea.
Plastics melt down into crude pyrolysis oil and can then be refined into fuel. So the fishing industry, for example, could recycle their old nets and plastics collected at sea into something usable.
This is the final product we get from refining crude pyrolysis oil. In this case, we have a light fuel suitable for fast engines, which can be used directly in boats.
There's hope that by working together, researchers, activists and the general public can counter one of the fastest growing threats to the world's oceans. If we fail to stop the surge of marine litter, the oceans in 3 decades' time could contain more plastics by weight than fish.